Hey everybody, welcome to a new video. In this video we are going to discuss something that comes up pretty often in the jitter world, the Max MSP jitter world, which is the discussion about CPU and GPU. So when to use GPU, when to use CPU, which objects actually work on the CPU and which objects actually work on the GPU. So we are going to find this out in this video. Let's give it a try. So first of all, let's define the CPU and the GPU. So the CPU is the core processing unit of your computer, right? It's in fact responsible for all the calculations that your computer is doing every second, every moment. It's often composed of 4 cores in modern computers, even 8 cores in bigger computers, more performant computers, and these cores are very good. In performing difficult calculations, basically, but they work in parallel. If there are 4 cores, they will work in parallel between them, but they work mostly serially on operations, right? Because the computer performs thousands of operations, billions of operations every second. So this is basically the gigahertz. How many operations the computer performs per second is the frequency at which it performs calculations. This is all done serially, so once one operation is finished, it comes in with the next operation, right? And for example, when I'm using the calculator and I say, okay, do 9 plus 6, and this is performed by the CPU. So it's very good in making difficult calculations, but it's not so fast in performing them. I mean, it's fast in a way, but it's just 4 cores, mostly. It's just 4 cores or 8 cores. Okay, so it's very good for difficult operations, complex operations, but is a limited amount of those you can do every second, and this is defined by the gigahertz of your processors and how many processors you've got. Okay, so that's what the CPU does. Then there is the GPU, which it's not so good in performing difficult calculations. It performs mostly simple calculations, but performs them on parallel. So what does it mean? So let's write this down. Simple calculations, thousands of cores. So the power of the GPU is that it has thousands of those cores which work in parallel. Okay, which means that at every point in time the GPU has thousands of those cores which perform those operations all at the same time. So this is why it's particularly efficient to work with videos on the GPU, because all the pixels in the videos get operated in parallel by those cores on the GPU, which makes the operation super fast. Because if we got like 3 million pixels in a video, I don't know, let's for example say a full HD video has 1920 by 1080 pixels, so it means it's 2,073,600 pixels. If we perform those operations on the CPU, it means that we just got 4 or 8 cores milling those numbers, grinding those numbers every second. But to perform 2 million operations, we need already quite some time to perform those operations on the CPU, because we only got a limited number of cores. While on the GPU, we got also a limited number of cores, but they are many. So they are in the order of thousands, which means in order to perform 2 million calculations, we split those 2 million calculations maybe in 1,000 cores, which makes it much more efficient for the computer to work on all those pixels at the same time, dividing the work on all those processors. Okay. This means that these processors are not so powerful, of course, like the processors we got in the CPU. So they cannot do the same complex operations. They are not so fast as the CPUs, but they are thousands, which means that then they can perform many more operations in the same amount of time. Okay, so that's why we want to work with a GPU when we are processing videos or images that are big, because they are made of thousands of pixels. And also, one of the differences is that with a CPU, for example, the operations are performed serially, we said, which means if we perform operation number 1, and then we perform operation number 2, we can already check the result at operation number 1 and see what the result was in order to influence the result of an operation number 2, right? But in the GPU we cannot do that because the operations are performed in parallel, which means we don't know what is happening on the other cores until the whole image is finished processing, okay? So we cannot access the informations from the result from the operations in the other cores. Okay, that's why CPU is a better fit for calculations that need to know which values we got from the previous operations. Okay, for example, let's say I have an array of 10 numbers. Okay, just an array or a buffer of 10 numbers, just the numbers. If I want to sum all those numbers to, let's say, a random number, one at a time, so all those numbers plus a random number, and every one of those 10 numbers has a random number assigned randomly. On the CPU, I could start, for example, with number 0, sum it to, so numbers at index 0, sum these to this random number. And then, when I check numbers 1, I could also check what happened, for example, when I was summing this random number to number 0. So, for example, I could check, okay, then make numbers 1 plus numbers 0, and then sum that to this random num, for example. So it means that I can check what is now the current value for number 0, okay? Because the operations are happening in a serial way, okay? Now, if I will do the same thing on the GPU, I have no way to know what happened on number 0 because those operations are happening in parallel, okay? So they are all happening at the same time. So these are all the operations that are happening at the same time, while on the CPU, the same thing will be more looking like that, happening on a serial way. So first this, then that, and that, and that, and instead on the GPU they all happen at the same time. Okay, so this is another difference between CPU and GPU. Now let's come into the Max world. Okay, so which objects actually work on the GPU in Max and which objects work on the GPU? Well, basically every object that has the GL world in its name works on the GPU. So for example, if I've got GGL texture, this is a GPU object. If I've got GGL grid shape, this is a GPU object. If I've got JIT world, doesn't have a GGL, but this is an object that works on the GPU. Actually, it's the main object that we need to work with objects with the GPU. So this is the GPU realm. Then we got all the objects that don't have GL in their name, which work on the CPU, and these objects includes, for example, jit.gen. Some people is confused if jit.gen works actually on the GPU or on the CPU. No, it works on the CPU. It's a CPU object that behaves a bit like a GPU object because it doesn't expose us an history of the previous operations. It also wants to behave like if it works in parallel on the single cells of a matrix, but actually works serially on them because it's a CPU object. So virtually, for what we are concerned, it behaves like if it will be like a shader that operates on all the single cells of the matrix at the same time. In practice, it doesn't do that. Okay, so jit.gen is a CPU object. Jit matrix as well, and then we got so we got jit.op, which is a bit old. jit.expr, all this stuff. I don't know, all these jitter, jit.pack, all the jitter objects. That work with matrices. They don't work on the GPU. If they work with matrices, it's not working on the GPU. Okay. While on the GPU we got GGL texture, which is basically the equivalent of a JIT matrix on the GPU. Then we got GGL pix, which is the equivalent of jit.gen. By the way, we also got jit.pix, which is an object that works on the CPU, which I don't know exactly why it exists, because it's exactly like jit.gen. It only works with matrices that have 4 planes and 2 dimensions, or 1 dimension, I suppose. So it's I don't know why this object actually exists, but it exists. It's a CPU object that behaves basically like jit.gen. So yeah, then we got GGL grid shape. For example, we got GGL slab, which is an object that works with shaders, so definitely on the GPU. And then we got the jit.gl shader, which works with shaders, so as well on the GPU. And yeah, that's a bit how it works. GGL mesh. Okay. So now let's talk briefly about shaders. What is a shader? A shader is a little program, can also be a big program, that works on the GPU. So it's a program that resides on the GPU memory and gets executed by the GPU, so by your graphic processor unit. So it's a program that you can write yourself, or you can use one of the main shaders that come inside the Max program. So it's written in this language called GLSL. We can take a look at the default shader that comes inside GGL shader, for example. That's how it looks like. It's composed of a vertex shader, an optional geometry shader, and then there is a fragment shader. Okay, while for example in GGL slab we will only work on a fragment shader. There is also a vertex shader, but it's mostly unused or unusable because the GGL slab only works on images and it's not really concerned with the vertices of the shape. So it's a texture processor, the GGL slab. Okay, so shaders work on the GPU. It's a little program that you can write yourself or use one of the shaders that come with Max, and it's divided into these two classes. Yeah, it's divided into the image processor like GGL slab and GGL pix, and then there is the shape processor, we could say, which is the GGL shader. Now the GGL shader, it's a shape processor because it can be attached to shapes like GGL grid shape. Okay, in this video I don't want to talk so much about shaders because I already have a lot of videos that talk about shaders, so if you are curious especially about shaders, you can check those videos. But in this video I just want to highlight the main difference between CPU and GPU. So yeah, shaders can work on images or shapes. GGL slab and GGL pix will work on images, and GGL shader will work with shapes. Okay. But they use the same language, apart from GGL pix, which uses the Gen language. GGL slab and GGL shader use the GLSL language. So shaders work definitely on the GPU. Now let's take a look at GGL texture. What is GGL texture? It's basically an image that resides on the GPU memory. Okay, so you put an image, you take it, you send it to the GPU memory. Okay, so it's not anymore on the CPU, it's on the GPU. And why is it convenient to have it on the GPU? Because then you can perform operations on the texture using, for example, GGL pix or GGL slab, or use it, for example, as a texture for an object and inputting it inside a shader and use it inside the shader also for some other calculations. And it's convenient to have it there because then you don't have to transfer it back and forth between the CPU and the GPU. You just transfer it once maybe, or you just create it directly an image on the GPU, and this image then is there on the GPU and can be performed and can be processed directly on the GPU in a super fast way. Because, this brings me to the next point, transferring stuff from the CPU to the GPU is a very costly process. Okay, this is a bottleneck mostly because you have to transfer a big amount of data from your CPU to the GPU, and this is very costly in terms of time, because it takes time. GPU, it's like in his own place. The CPU is his own place. If you want to transfer stuff from one place to the other, it's going to take time. So you never want to do something like that. Mostly never. You never want to bang a matrix inside the texture at every frame. Okay, like something like that. Let's actually make a little test. You never want to bang this matrix inside this texture at every frame, okay? This is something that is going to be super costly and you never want to do it. For example, if you want to send a movie inside the texture, you can give it directly the output texture attribute, which will make it directly output a texture, okay? In fact, it's already outputting a texture. Output texture works only when you got a JIT world object, because as we said in a lot of videos, the JIT world object is responsible for all the GPU processing stuff that happens, so you need to have one. And in fact, the JIT movie object is actually drawing to through the same context that I created in the JIT world. Okay, so it needs the same drawing context. If I change the drawing context, this is not working anymore. Okay, so if an object is outputting a texture, like for example the JIT movie or the JIT grab with output texture, then this means that these objects need to have a JIT world object or an OpenGL context in place. So let's actually put these two objects here, JIT movie with output texture 1. Oops. Output texture 1. This is going to be a GPU object. Okay, JIT movie with output texture 0 is going to be a CPU object. So the same object can work either on the GPU or on the CPU according to the output texture attribute that you give it. I didn't talk about it until now, but I will do it now. Max uses OpenGL to work with the GPU. So what is OpenGL? Is an API which is responsible for describing a set of instructions that the GPU has to follow. So basically Max uses this API to send commands to the GPU, which then executes them and displays stuff on our window. So OpenGL is the name of the game, and OpenGL is what Max uses and a lot of other programs uses to represent computer graphics, to work with computer graphics. So yeah, output texture transforms basically an object from a CPU realm into the GPU realm, which is basically the way to go when you want to work with videos or the JIT grab object, so with the webcam. And yes, so one thing you don't want to do is to mix those two realms at every frame. It's no problem if you send a matrix into a texture just once, like for example at the beginning of when you load your patch, for example with a load bang, you send a bang into this JIT matrix and this can transfer into a texture. It's no problem if you just do it once, okay? This you can definitely do it. You just don't want to do it too often. So you can think about your CPU like the client, this is how OpenGL describes it, and the GPU like the server. So the client asks stuff to the GPU, so it sends it instructions, and the GPU makes the calculation and sends you the result back. You don't just want to send those instructions too often to the GPU. That's why in GL3 we got also objects like the ggl.tf, which makes this process much more efficient, this process of sending instructions to the GPU, because you just send it once and then the calculations keep on happening on the CPU with the transform feedback system, which makes it super efficient, because we are not transferring any more informations to the CPU from the CPU to the GPU at every frame, but we just do it once and then the transfer feedback takes care of reusing the information from the previous frame. So transfer feedback video, I got some stuff about it, but I think I will do a more in-depth video soon. So yeah, exactly. Basically, you don't want to mix matrices and texture. You don't want to use the wrong thing for the wrong input. For example, most of the times the objects will tell you which input they actually need. For example, the GGL mesh works with matrices. It doesn't work with textures, okay? If you're going to send it a texture, it's going to convert it into a matrix first and then using it. Because it works with data that comes from the CPU, because we have to send it data first from the CPU, and then the data gets uploaded on the GPU, and then the GGL mesh can use it. So it doesn't work with data that comes directly from the GPU. Okay, so you only want to use matrices with the GGL mesh inputs. Okay, then we got, for example, the GGL material, another GPU object. GGL material, for example, can receive a texture or a matrix. It's basically mostly going to be more efficient to send it textures, because the GGL material is actually just a shader generator, which generates a shader which we can actually even check with get GL3 shader. By the way, I'm in GL3 because that's the way to go now, but the same concept is valid also for GL2. Let's actually connect it to the GGL grid shape and send this message to the GGL grid shape. Suck. Okay, I think before it creates the real shader, I think we have to activate the... Exactly. Now, as you can see, it looks different. The shaders is much more complex. That's because it needed first to activate the world, and then it will create the proper shader. So yeah, get GL3 material will give you the shader that the GGL material objects creates automatically when connected to a shape. So if we will connect a texture to one of the GGL material inputs, for example the diffuse, let's try like this, exactly this is working, and let's query the shader again, exactly. Now we got another parameter called diffuser, which is a texture, in fact you can see is a type integer and default is 0. And this texture it's going to get used inside the fragment shader to give the diffuse color to the object. So this is always better to be a texture. You never want this to be a matrix. I mean, you could have a matrix as well if you don't send it at every frame, as we said before. But it's mostly better to use a texture, because shaders only work with textures. They work with data that has been sent to the GPU as textures. Okay, so the texture is a buffer of numbers that resides on the GPU, and the GGL material and shaders in general only work with textures. Okay, they don't work. They can also work with arrays from the CPU. That's okay. We can also use arrays from the CPU using the GGL mesh object, for example. But mostly you want to use textures. So when are you using actually a texture? Only when you're working with shaders. So if you're working with GGL material, if you're working with slab, if you're working with GGL pics, then you want to use textures. But if you're not working with any one of those objects, in general, if you're not working with shaders, you don't want to use a texture. That's the rule of thumb. Okay? So, or if you're not working with GGL objects, then you don't want to use a texture. One exception is the GGL mesh object, which will not accept textures, but will accept matrices, okay? And in fact, also the GGL NURBS object, as a control matrix, it will accept only a matrix. So, in general, those GPU objects that don't work with visuals, mostly they want, with video or images data, they mostly want data from the CPU in the form of matrices, and then this data is going to be transferred to the GPU, and then they're going to use it, but this data must be transferred from the client side, so from the CPU, in a matrix form. So again, let's say this again, never mix matrix and textures, never use textures unless we're using shaders, and GGL material is a shader as well. GGL mesh only wants matrices, GGL NURBS only wants matrices, and that's basically it. If you're working with images or video, you mostly always want to use textures and not matrices. I will go further into details into this topic if there is the need, so let me know in the comments if you found this useful or confusing. I know it was confusing because I explained stuff in a confusing way, but if you got some specific questions, just let me know in the comments or write me, and if you're patrons of mine, write me on Discord or Patreon. And yeah, hope this was useful. And now you have a bit more clear idea on when to use the GPU and when to use the CPU. So it's not that the GPU is always the way to go, okay? It has a function, and for some stuff it's better to use the GPU, for some stuff it's better to use the CPU. You just have to know when to do one or the other thing, and I hope this video helped to clarify exactly when you have to use one or the other. Okay, so this was it. As always, I will upload this patch on the Patreon for free, and yeah, let me know if this was clear or unclear, if there is more stuff you want to discuss about. Okay, so yeah, thank you for following, and see you soon. Ciao ciao.